You might remember that in transverse stability, there are 4 reference points that are used to do the majority of calculations. The first point is K, or the keel. K is located at the very bottom of the ship. You'll see that most of the other points in stability are measured with reference to the keel. The next point is G, or the ship's center of gravity. The mass of the ship is evenly distributed around this point, so you can think of this point as the spot where gravity is acting. If you move weights around on the ship, say by ballasting or by loading cargo, you change the location of the ship's center of gravity. The vertical height of the center of gravity above the keel is known as kg. The next point is B, or the center of buoyancy. This is the geometric center of the underwater part of the ship. Because of Archimedes' principle, we can say that the force of buoyancy is centered on this point, and is pushing back with equal force to the center of gravity to keep the ship afloat. Kb is the vertical height of the center of buoyancy above the keel. Finally, there's the metacenter. When a ship heels back and forth, its center of buoyancy will shift from side to side and describe an arc. The point at the center of this arc is known as the metacenter. The metacenter is an entirely theoretical point that is only used for the purposes of calculations. For small angles of heel, say up to 10 or 15 degrees, the metacenter is considered to be a fixed point. However, larger angles will cause the ship's metacenter to move. From K to M is called the height of the metacenter. From G to M is called the metacentric height. Be sure not to confuse the two because the names are very similar. GM, or the metacentric height, is a very important number in the stability of ships. The ship's GM, measured in meters, serves as an indication to how stable it is, or how well it resists rolling. A greater GM means that the ship is more stable or stiffer, meaning it will return upright faster. A smaller GM means that the ship is less stable or more tender, meaning that it will not resist rolling as much and not return upright as easily. We're going to see that there are regulations in place that say how big a ship's GM needs to be in order for it to sail. When a ship is heeling, in this case at an angle of 20 degrees, the center of buoyancy shifts to represent the new hull shape underwater, but always remains vertically under the metacenter. The center of gravity and the center of buoyancy are no longer directly in line vertically, which means that a rotational force is being created to bring the ship back upright. If we draw a line from the center of gravity to a new point, Z, what we are looking at is called the righting lever, or GZ. The bigger the righting lever, the more force is being applied to bring the ship back upright. You can see that if you lower the center of gravity on the ship, say by adding ballast or cargo, the righting lever, GZ, also increases. The end result is a stiffer ship that will resist heeling more than if the center of gravity were up high. Calculating the righting lever is really just a simple trig calculation. You can see that these reference points form a right-angled triangle with GM as the hypotenuse and GZ as the opposite side to the angle of heel. If you rearrange the sine function to solve for GZ, you get the formula GZ equals GM times the sine of the angle of the heel, or theta. This formula is widely used to calculate the righting levers for various angles of heel, as long as you know the value of the ship's GM. The final thing you can do is to calculate the ship's righting moment based on its GZ. The righting moment is a measure of the amount of force, or torque, that is bringing the ship back upright, usually measured in ton-meters. Remember that the forces of gravity and buoyancy are in opposition to each other to keep the ship afloat. This means that the force of buoyancy and the force of gravity are equal and are both represented by the ship's displacement. To calculate the righting moment in ton-meters, multiply the righting lever, or GZ, by the ship's displacement. This will give you the righting moment in ton-meters. Make sure that you understand these reference points and these formulas, because they will be very important for the rest of this unit.